Hello everybody. Hope you guys are doing well. So today we will be starting with head first design patterns, and we'll try to understand some design patterns, and then we'll see what is the use and why, what is the need to study this, and then we'll go on from there. Okay, design patterns. Now, um, the first is basically why do we need to understand, or basically let's understand the first the simple duck dilemma or the duck problem that we have, and we'll try to understand like what are the drawbacks of doing programming in that way, and we'll try to see. Now okay, now let's start with a simple simu duck app. So Joe works for a company that makes some highly successful duck pond simulation game called as simu duck. The game can show a large variety of duck species swimming and making quacking sounds. The initial design of the system used the OVER technique and created one duck superclass from all other duck types. Okay, so basically now we are going to define, we are going to understand like what is the, um, like why do we need design patterns. So the first thing that we are going to understand is duck dilemma, or like what's the problem with our normal programming style, and why do we specifically need design patterns to understand. Now Joe is working for a company that makes a successful pond. So this is our pond, right? Now in this pond there are many ducks that we can have. The first is there are two types of duck that we are talking about. So first is basically a mallard duck, and second is a red-head duck, right? The first is our um, mallard duck, and then second is basically a redhead. So the only okay, so like by mallard, so mallard is basically like a facial structure or something. Okay, so these are how mallard ducks are. They have blue color eyes and nose. Um, these are basically wild ducks. So wild ducks are basically called as mallard ducks. So like these two types are mallard, and then we have, oh, let's have this as like wild duck. Okay, so now all ducks are going to swim. So let's have this in our parent class, right? If you are doing, then all ducks are going to quack. That is, they are going to make some sound. All ducks are going to swim. So we are going to have the swim here class as well, swim method as well. And then we are going to have something called as a display. So what we are going to do is, the difference between wild ducks and red ducks or different varieties of ducks is the way they appear, right? Or in other words, they are a display feature, right? So we are going to change that. Okay, so for what we are going to do here is, basically we are going to override the display method, and then once when we override the display method, um, we are going to implement these behavior, right? So then the wild duck will implement its own uh, so in the wild duck you have an um we have a duck who will have its own facial display, and then in red you will have another duck which will have its own facial recognition. So now the last year the company has been under increased pressure from competitors, right? So they need something really impressive to show that upcoming shoulder. So this is basically a game where this is a pond, right? So this is how our code is going to look. So we are going to have a class that is going to contain all the generic behaviors. Uh, for example, coax, and display. Now this will be this. So depending upon the type of the duck we are using, we are assuming that all ducks are going to quack and they are going to swim, right? So the only difference between them is how they are going to be, or like how they are going to facially recognize. I mean, their facial structure or the way they look. Now, what if you want to add another method, right? Or in here, suppose we want to add a method called as um, suppose we want to add another characteristics. Suppose now the executive decides that flying ducks is just what the simulator needs to blow away the other ducks in competitors, and of course, Joe managers told them it will be a not be a problem for Joe to just whip something. To differentiate between other ducks, we are going to differentiate between other duck games. What we're saying is, in our game, our ducks can fly as well. So now we are going to add a common method in our main class. The moment we add this method, now all the class which are present are going to or are inheriting from this main class will be getting this, right. So the wild duck will get its own, then the red duck will get its own, and then if you have any other type of duck, which is so like we have one more type here. Basically, other than these two, anything other than these two, basically we have our uh, other duck types. Like so, this is other duck. So basically, this is going to so basically this is going what this is going to do is now all the duck are going to be inheriting from this, right. So this is now present in all the class. Now, but something went horribly wrong. Now, Joe failed to notice that not all subclass of duck. So what he's saying is, so what if in this other duck types we have something called as a rubber duck? A rubber duck is basically nothing but an artificial duck, right? Now, which is basically, so what if we have a rubber duck? Now, this rubber duck does not have any feature called as fly, but even though we are going to have one parent class and make the children inherent from it. So what is going to have this? Even though like even though this type of duck did not want uh, did not want the fly method, still it will be getting a fly method because it is going to inherit it from this parent class, right. So that is not a very good solution, because we are we are forcing it to perform inheritance, right. Okay, now what about, so the other way, if inheritance is not an option, then we think Joe realized that so inheriting was not a probably very good option, because he just got a memo saying that the executives now want to update the product every 6 months in ways they haven't yet decided. So what? So Joe knows the spec will keep changing, and he'll be forced to look. So basically, what is going to have is, so if I have, so this is the base class problem that is going to come in, right. Like what if this method is going to change every time? So every time I change this method, all the classes which are inheriting from this Like for example, this wild duck, this red-headed duck, another duck types will also have to change their way of implementing, right? Because the inheriting method has now been changed. So then we need a cleaner way to have the same functionality, but not all of the duck types can fly or quack, right? For this, what we do is we use something called as an instead of using inheritance, we say let's use interfaces, right? So what we do is basically we create so we have our main duck class basically. So how we going to interface implement the same thing using interface? So then we have our main class. This is the main duck class. Now here we are going to have in two methods, right? One is swim, the other that we have is display, right? Now so we have these two methods being present in our interface, right? So now what we are going to say is, now whatever yeah, so the problem was with fly, right? We don't want all class to we only want those class which can fly uh, to have that method, right? So what we are going to do is, so this is going to remain as it is, right? We are going to still inherit from, this is be my inheritance, right? So these two or these methods will be in common, right? So I'm going to have your um no, let's have it this way. It's not working. So this is going to be my interface, and then I'm going to have three classes, right? So basically, this is my mailer duck, and then I have the red one, and then I have other duck types. So this is my other. Now what I am saying is, if so, the problem was with fly, right? So that fly method is not available in all, right? So instead of inheriting, we do something called as an interface. So by interfacing, what we are doing is whichever class is going to implement this interface, uh, interface is like a contract, right? So whichever class or whichever type of duck is going to implement the interface, it will have to implement the fly duck method, right? The fly duck method, right? So a malware duck has a, this is my interface. So this is basically like a contract. Now the other duck type, for example, the rubber duck does not have the fly method, right? So it is not going to implement it. Rudder ducks can fly, so then it will be also implementing the same class. It's so is this design a better version? Now is this, so what we have done is we have implemented an interface. So this is flyable, and then whichever birds can fly are going to implement this interface. Similarly, we have another feature called as quacking, right? So what we are going to do is we are going to put quack feature outside over here. So whichever, this is my quack interface, right? This is my quack. So whichever ducks are going to quack or whatever ducks will be quacking are going to implement this interface. So uh, this is going to implement, no, this is, so this duck is going to implement because, so since this is implementing, What are we going to say that this duck is going to, it's going to follow this contract, right? Similarly, we say our other duck can also quack, so it is going to implement this interface and then follow the design. The only way the ducks are supposed to fly with implement that interface and have a fly method. And okay. So again, so what we have done here is now one thing we have overcome this. So this class will be implement, or this interface will be implemented by only those methods or by only those subclasses which really have that feature, right? So we have, instead of having it like mandatory forcing because of inheritance, now we have gotten rid of that. But then is this design a good? Now this is a very dumb idea. Now why? So the problem is, which is going to happen here is, so what if we are going to make a change to in all 48 of flying? Hmm. So we know that, yeah. So one thing that we have gotten rid is of inheritance, right? But while having the subclass implement the flyable or quackable solves part of the problem. No inappropriate. Now, one problem that we have solved is any ducks that cannot fly will not implement, right? Now, this is basically completely going to destroy our code behavior. This is going to be a maintenance issue, right? Because each duck is going to implement, will create a different way of implementing the same code, right? So at this point, you might be waiting for a design pattern to come riding on a white horse and save the day. But what fun will that be? No, we are not going to figure. We are going to figure out the solution the old-fashioned way. So what problem is going to happen is, since each, so right now we only have two subclasses here that are implementing this same method, right? So it is very easy to maintain this. Now, what if we have more than 100 types of ducks, and each duck is going to implement his own fly method? Maintaining that code is going to be a heck lot of a problem, right? However, although interfaces does solve the problem of inheritance, that is only the class which needs that behavior is going to implement it. But this is not a very perfect solution, right? Still, there are issues with this solution, right? So then, how to solve, or like what is our goal? Okay, so like what do we want to do is basically, um, so we want to design our software in such a way that changing one part is not going to affect the other part. So our software should be written or designed in such a way that if there is any dependency on this or anyone inheriting or causing any issue, like if we add and if we make any changes to this original software, the neighboring code shouldn't be affected by this. The changes to the software shouldn't affect any functionality, or we shouldn't spend debugging other parts of the code. Now, okay. Now, what's the one thing that you can count in software development, no matter where you work, that you're building, what language you're programming on? What's the one thing? So, the one thing that we see is basically change. No matter how well you design the application, over time, an application must grow. So, what he's trying to say is, in order to keep our app relevant in the market, or in order to keep our website relevant, or to run our business, we would have to make changes to the software, right? But then the changes, or the if the software initially is written in such a way that changes to this original software not damaging other pieces of code, and it would be very easy, right, for the developers to maintain the code and make the changes, right? So now we know that inheritance is not a inheritance hasn't worked well. Neither has interfaces. Uh, except Java interface. Now there is one more problem with interfaces, right? Now only Java. So now not all language are going to support this type of inter contract thing, right? For example, in Python does not have any feature which is any private access modifier, right? So then this means that whatever we need to modify a behavior, we are forced to track down and change it in all different subclasses where the behavior is defined. So this is basically going to introduce our problem. So this is our goal, right? So what the design principle will state is take parts that vary and encapsulate them so that later you can alter or extend the parts that vary without affecting those you don't. In other words, if you got some parts of a code that is changing, say with every new requirement, then you know you have got a behavior that needs to be pulled and separated out from all the stuff that doesn't change. Now, our first how many design principles we'll spend more time on these throughout the book. So basically, first principle that we want to study or we want to do with designing is basically we need to understand where our understand the different aspects of the code that varies and separate them from what is going to from what is from what uh, okay, so separate the different behaviors so that any changes to the separate behaviors does not affect the code and have the common behaviors being inherited. Now here's another way to think of this principle. Now take the parts that vary, encapsulate them so that later you can alter or extend the parts that you can vary without affecting that doesn't. This is basically our first principle. The separating what changes from what stays the same. Now where do we start? As far as we can tell, other than the problems with fly and quack, the duck class is working with. So the only big issue that we are happening is this method, right? So now we got rid of back the drawbacks of inheritance, right? And we know that fly and quack are the parts of the duck class that vary across ducks. So if anything is behavior, so what we are going to do is we are going to pull both the methods out of the duck class and create a new set of classes to represent this behavior. So the first design principle is going to say whatever is going to change, you pull it out and put it in a different behavior, in a different class. So this is how we started, right? So initially we had everything being put up here, but we said putting this is bad. So what we did, we got out and we started using interface. But then we said no, that is also a bad thing, right? Now what we uh, did is what we did is so then we later on recognized that instead of using interface, what we should be really doing is basically adding changing behavior to one class and the rest which is common in other class. So you're going to add the changing so this is my changing behavior. This is my changing behavior class. So anything which is changed is going to come here. And this is going to be my normal class. So this is my duck class, the main class which still has the swim and display methods, right? Designing that. So now, how are we going to design the set of classes that implement fly and quack? We keep things simple and flexible. After it was the inflexibility in the duck behaviors that is getting into trouble, right? And we want to know. We want to assign behaviors to the instances of duck. For example, we might want to instantiate a new malloc instance and initialize it with the specific type. Now we are saying is how and when is this class going to look like. So this time it won't be duck classes that will implement the flying, and instead we make a set of classes whose entire reason for living is to represent a behavior. Okay, this is contrast the way before where a behavior either came from a concurrent implementation, a superclass, or by providing a specialized in the subclass. In both cases, We were relying on implementation. Now we were locked into using that specific implementation, and there was what he's going to do is uh, but did we say no, no? From now on, the duck behaviors will live in a separate class, a class that implements a particular behavior interface. That way, the duck classes won't need to know any of the implementation details for their own behaviors. What is he doing here? Mm. Now, how are we going to solve? So when we take out in uh, so no, fly and quack. We'll use an interface to represent each behavior. For instance, fly bear and quack behavior, and each implementation of a behavior will implement one of those interfaces. So I have fly behavior, and then This is my behavior, and we have fly with wings, and we have. Now, how is he solving that issue? We'll use an interface. So this is an interface. So this is my, and each implementation of a behavior will implement one of those. That's just what we were trying to do, right? So instead of inheritance, we then put it in interface. But then interfacing also was an issue because but then this is still an issue, right? So like what if we have more numbers? So what are we doing differently here? These are interfaces, right? Flyable and quackable. We know that fly and quack are parts of the drug that varies across the duck. So to separate this behavior, we'll both pull methods out of the duck class and create a new set of classes. This is a new set which is going to represent my behavior, right? For example, flying and quacking. Now, how do we are going to design the set of classes that implement the fly and the quack? We'd like to keep things flexible. After all, it was the inflexibility in the duck behavior that got us into the trouble, right? And with that, we want to assign behaviors to the instances of the duck. For example, we might want to instantiate a new mallard duck instance and initialize it with a specific type of flying behavior. And while we are there, why not make sure that we change the behavior of a duck dynamically? In other words, we should include behavior setter methods in duck classes so that we can say change the mallard duck's flying behavior at runtime. We use an interface to represent each behavior. For instance, fly behavior and quack behavior, and each implementation of a behavior will implement one of those. So fly behavior, no. Instead, we'll make a set of classes whose entire reason for living is to represent a behavior. For example, quacking, squeaking. No, no, we'll use an interface to represent each behavior. So I'm having an, but then he said, okay, so what I'm going to do is now, previously I was, the methods were, okay, what I was doing here is, uh, I guess what he's trying to say here is, So here we defined two interfaces, and whatever classes needed that function was going to implement that class and follow the contract. But now what we are going to do is uh, it's the same thing, right? Now we have the two interfaces along with the corresponding classes that implement each concurrent behavior. So okay, let's get rid of all these things first. What we say is that changing behavior you put in an interface, and then you uh, have two class, or like whatever has that behavior is okay. So let's say copy paste, and then let's reorder. And this is basically so this is my fly behavior interface, right? And I'm going to have two things here. This fly with wings, and then you have fly with fly no way. This is an interface. But then I'm still using that interface issue, right? So, like, how is this interface different? Oh, this is a. There is no class involved here, I guess. But how is that changing? So this is my fly with wing. So this is a class that has a fly with wings. This is my class name, right? When it comes in, and this is my method. So I fly with this. So this is basically, this is directly an interface. Remember, this is an interface. This is also an interface. But then what is the difference is here, these methods are directly going to implement. So this malreduc is, wait, no, but that malreduc is a type of class, right? Okay, let's see what is happening. I'm not still not able to get why he's saying that it's a bad way. Like, what's the difference between the two? No. So the first thing we thought is inheritance, right? Now, in second, first we solved the inheritance problem. Now we are come with something called as. Now this is also an interface, right? So what is the issue with interface? Yeah. So as I said, as these number of classes increases, we need more and more classes, right? So like more and more behaviors are there, and more problems are we going to run. So because more implementation will happen, right? To fix this, someone might suggest use interfaces for. This is the drawback, right? So if you have more number of ducks present in here, each duck will be implementing this. So like this will grow. Each will have its own implementation. Now, 50 ducks type fly, you must. So we are going to implement the same method 50 times for each. That is what is code duplication, right? Flying will be flying, right? I mean, it is not going to change. Flying basically will be when a bird is in the air or like flapping wings. The problem is now each will implement his own fly method, although it was supposed to be. Uh, okay, there is one more big thing. Now, what if once we have implemented this interface, what if we further want to change it? So, whenever we want to change that method, we need to go into the implement class and make the changes there. That means if there is any issue, or if suppose if we say a rubber duck, so we first have to identify where that has been implemented, and there we have to go and change, right? Now this is not, so when we are going to type a code, we are going to do something at compile time, right? So instead what we said is, well, instead let's have an interface and let that interface, okay, so we are going, a class is going to implement this interface. Now what this class is really going to do is, oh I see, so what we have done is we have taken out this fly behavior right now, and this is going to have a method, say this has a fly method in present here, so this is a fly method, okay. Now these are two classes, we have fly with wings and fly nowhere, so these are going to implement this fly behavior, right? So what we are going to do is, so in our duck class, we are going to pass the we are going to pass this object reference, so that what we can do is, since we have the reference, now we can directly modify this behavior as and when we want. Is that what is happening? So we are going to do composition over inheritance, over inheritance, right? I see. Yeah, basically, what we are doing is we are going to pass the reference to the instead of performing. Uh, yeah, basically, what you are going to do is you are going to create. You basically we are going to achieve composition, right? So there are two ways to achieve composition. One is dependency injection and dependency instantiation. So here we are using instantiation. So by dependency instantiation, what we are going to do is the we are going to we are going to pass the reference of the fly behavior or sorry, the the fly with wings class, so that at runtime we can change the behavior, right? So once you have the reference to this class, and this class is going to implement this interface. So now we are going to do some, we are going to pass the reference, right? So when we pass the reference, we can access all the methods that is being present here. So this is going to be implemented by the class, by this class, and this reference has been passed. So basically we are changing things on runtime, right? That is what is the duck dilemma. Or basically, so we are going to change things on runtime by passing the reference, right? Now there are two ways you can do that composition thing. Now since we already have the reference, we can now directly implement the behavior as and when we want on the fly, right? Okay, so we have moved to a composition type of relationship where we are doing uh, okay. So remember what was the problem that we are facing? Uh-huh. So each pattern that we are going to develop is going to have so each program or like each application that we are going to develop, we need the end goal of our the end goal is basically to make sure that uh, our patterns are in check, right? I mean, we are using or we are writing code in such a way that can be that can be easily first of all it should be maintainable code, easily accessible to be maintained, right? The second thing that we for that, so there are certain OOP features that make our code reusable, right? So based on how and what our application will behave, we are going to have specific or we are going to implement a specific type of pattern, or we are going to write in such code in such a way that it is going to uh, follow that specific pattern. Okay. So now this is basically related to how our application should behave or run, right? So it basically comes under behavioral patterns. Like basically we are dealing with behavioral or the behavior of our application, right? If we see design patterns, um, like they can be classified into four broad categories. Like so, patterns can be classified into different categories. The first category that we are going to have is something called as creational. Basically, this is related to creating the object. How should we create the object? So that is when we are dealing with creating or creational patterns. Then is something called as structural patterns. Okay, then we have uh, structural patterns. Now then we have something called as something that deals with the behavior is behavioral patterns. And then we have so yeah, we have broad three categories: creational patterns, structural patterns, and behavioral patterns. Now what does creational pattern deal with? Or like what are we going to study when we are yeah, basically we are going to yeah, this is basically more related to object creation. Like how should we create the object? How and where should the object creation happen? This is related to object creation, as you said. Structural. So structure is basically when we change a code in one part, the other part shouldn't be affected. Like when we make changes to one or like to one part of the code, the other shouldn't be affected. Now behavioral is when we are adding additional behaviors, I guess. So these are basically related to uh, communication between objects, how they interact, and how responsibilities are distributed between objects. So this is responsibilities. Uh, Responsibilities between objects. So this is broadly how we classify, right? So depending upon what are we working with or what our problem is. For example, is it an issue with the way the object is getting created, or is it an issue with our structure? For example, making changes to one affecting the other, or is it the issue with the behavior? That is how different objects are interacting with each other. So based on that, we are going to select the specific pattern that we want. And there is something called as solid principle. Let's see that. Okay, so now there is a slight difference, right? So solid principles are basically the object oriented design principles or a guide that helps how users are going to like how are we going to write the code if something is written from scratch. So what does the design pattern do is design, so based on what our problem is, like based on the type of the pattern of the problem that we are trying to solve, there is an already available solution for everything. We just need to link, so that pattern is basically going to follow the solid principles. Instead of us writing it from scratch, like trying to understand everything from scratch, there are certain readily available solutions that are available. So based on how our problem is and what problems are we facing when we are trying to write the code, so based on that we are just going to match our pattern problem and with the readily available design patterns, and then we are just going to use that specific pattern to implement uh, our goal, right? So basically, design patterns are readily available solutions based on like what common problems can do. So based on the common problems that people are having, like certain patterns have been developed, so that instead of the developer um, writing code from scratch, like trying to understand where the code can break or what is not break, where is an issue while maintaining the flexibility of the code, we kind of use certain already available patterns and we just match the pattern. So pattern is something like a leaves, right? On leaves you see a specific pattern, right? So based on the leaves, you based on the type of that leaves pattern you have, you try to identify like what type of leaf that is. On similar lines, based on readily available based on what our problem is, so we are there are already readily available solution, we are just going to match and fit into which type of uh, or like which type of problem are we running in, and then once we identify the problem we are just going to uh, m- uh, use that in our code. Now why is it important? Because it's like many libraries or many frameworks have been already developed using these patterns, right? So the more we know about these patterns, the more we are going to know how the code is structured, and why it is structured that way, and why that library or a framework is a better use case than writing from scratch. Like for example, Spring Boot, right? It is based on a design pattern, right? So if you know the design pattern, then you can understand how the code has been implemented in the under the hood, right? So once you have that access, then it becomes very easy to use the different uh, features that that library or framework provide. So I guess this is all for today's lecture. I hope you guys liked it, and see you in the next one. Till that time, take care.